Okay, now, it seems that now we are ready to just go ahead and just to start working with two models. We have been able so far to use the loop package and the loop function, and to see that how we can just use, for example, in terms of, for example, assessments on one single and individual Bayesian models. But there was one thing in our model that, if you remember, for example, from the model that we did, if I just go back to, let's say, for example, for the Lou woman, the package, there was a number that it was for ELPD Lou, which it was for a kind of a measure for accuracy of the prediction of your model, for the expected log of probability, expected log of predictive density. And now the thing is that I said that please keep that number where you are. We are just going to use that and apply that when we have two models in order to compare them together. Now, in order to have two models, I'm just going to, if you remember, we had, before we defined the model, which we called that the model no interactions. If you remember, the model that we had, it just came from the empty cars datasets. And in that empty car datasets, we designed the model in a way that we can predict and model mileage per gallons based on the horsepowers and the weight of the car. And now we saw the inferences that we have made about the intercepts and the slope as a coefficients for both the covariates of the horsepower and the weights of that car. Okay, now, this model was in the non-Bayesian frameworks. As long as you have the R-stand arm installed and ready on your computer, you can double check that also here. We can just go ahead and convert that model into, let's see, R-stand arm. Okay, we do not have that model. Let's go with it and install that model. We just go ahead and say that install packages. I'm just going to go ahead with R-stand arm. I'm just going to execute the line. I'm just going to press the yes, and the model and the package is going to be installed on my system. Then we are just going to be ready to convert the model, which it had no interactions, into the non-Bayesian framework into the Bayesian one, simply by changing some parameters in our model. But you know, so far, as long as we assume that we should be on the, I should say, in the tutorials, after 32 tutorials, you see that the syntaxes between the Bayesian and non-Bayesian in the regression analysis somehow seems similar, but the interpretation and the philosophy behind each one is significant. Okay, now it seems that we should have our stand arm there. I'm just gonna with the package with the library command, with the R-stand arm, to just have it ready to just go ahead with it. And now with the model with no interaction, let's just come here. If it says that the model no interaction but with Bayesian. Sorry, the name is gonna be a little bit too long, and the reason is just for the sake of the demonstrations that we just have somehow a good understanding of what the model is going to talk about. Then I'm just going to go ahead simply with the function of stand GLM, and the thing which I have, I'm just going to copy paste whatever I had for the formula in, I should say, in the model, which it was mile per gallon. It's going to be, I should say, for example, as a function of the horsepower plus the weight of the car. I can just go to the next line. I just go ahead to say that the data is going to be empty cars, and however, depending on your choice, we can just go ahead and just press the help button there and see that what other things that we can just put inside the functions that if we want. You see that, for example, we have the choice of the priors. We just go ahead with, I should say, with the default priors, which the system just is gonna just take for it. But also, if you want, you can just go ahead to assign the number of the chains and also the number of the iterations for your model. Then we do not want to just go to that much specificity, because the purpose is something different. We do not want to just go for the, I should say, the model specificity. We just want to demonstrate how we can compare two models. Then I'm just going to execute that line, execute that command by pressing Control Enter, and we see that the formula is missing. It's Oh, okay. Look at that. The spelling of the formula was wrong. Maybe I shouldn't have written that because there is no need to write, I should say, the formula, but I did it. And now I'm just going to execute the line. And you see that it took so fast because the number of the iterations that we had, it's now around 2,000 iterations. And now we see that we did with 4 chains that it took, I should say, that much time to execute that line. Also, within the non-Bayesian framework, we had the model. It says that the model reach interaction. I'm just going to execute this. You see the specificity of the formula, which is going to be this one. I'm just going to produce the same thing. Model with interaction, but within a Bayesian framework. Somehow, as you notice that, the syntaxes is going to be incredibly similar, but as you learned so far, after 32 tutorials, the interpretation and the philosophy behind the Bayesian analysis is somehow widely and vastly different. Okay, for the formula, I'm just going to right now include also the interaction as the thing which I have here. I have MPG, which is going to be taken as a function of the horsepower plus the weight plus also the interaction term, which is the interaction between the horsepower and the weight. I'm just going to do that, and I'm just going to go ahead to just write the type of the data that I'm just going to have. It's going to be the empty cars. And it seems that everything is ready. I'm just going to double check that the formula spelling is right, and it seems that this is going to be fine. Now, it's ready to execute that code. I'm just going to press Control Enter, and you see that the processing is being done. The warm up and the sampling, 4 chains, each chain for 1,000, I should say, iterations. And now the sampling now then. Okay, now you see that it took a little bit longer, this model, because we had an interaction term inside that model to just define that model. Okay, now we do not need to just go to just write the summary of these models. However, the thing that we are just going to do, we are just going to simply compare these two models. As I said, the topic is going to be compare two models. Although you can just be this package, with below you can compare more than 2 models with each other, but we just go ahead just to compare the models with interactions and the models without the interactions, because we do not know which one has a better accuracy in the prediction, and that's why we just want to compare that. Okay. As I just want to show to you the thing which we did, I'm just going to go back to the whiteboard which I had. In this slide, I just want to draw your attention again to the theoretical predictive accuracy measures that we defined before as the expected log of probability density, which we defined it to be like that. I assume that you please go back to the tutorials which we had before, because the examples which we had for these simple concepts, when we talked about, for example, these two new women coming inside the schools that we had, it's going to be very intuitive to learn and get the concepts of this one, of these theoretical measures that we have. Now, that I'm just going to compare these two models. Again, I'm just going to go back to just use and borrow these theoretical measures as the ELPD. As I said, it's going to be the measure of predictive accuracy of the model then. Each model that you have here, it's going to be either model with interaction and model without the interaction. Each one is going to bring a kind of a theoretical ELPD measure. Each one has a measure of its predictive accuracy. And now we are just going to convert these two models together. How to do that? It's going to be very simple. I'm just going to go ahead. You see that when you type Loo, if you are in the R Studio, you have, let's say, the R Loo compare. And now, the thing which is going to happen here is this. We just go to the Loo compare and we have the functions opens. Now, let's see what things we have to just put there. It's going to be very easy probably. You think that, okay, I'm just going to compare 2 models, then I have to just put 2 models as an objects inside that model then that's going to be the case. I'm just going to go ahead and put these 2 models as a comparisons. I'm just going to go ahead. For the first model, I'm going to go ahead with the model with no interaction in the Bayesian framework, and also the other model is going to be the model with interaction within the Bayesian context. I think these are going to be all the things which I'm just going to start with. You see that you can just put many other arguments. You can see that you can just put many other arguments. For example, the Lu concern, for example, you can have the Lu, you can have the Vec, Watanabe, or you can have the K-fold. You're not going to talk about this one. It's just simply about the Lu compare within the Lu itself. Then, as a result, that's going to be the main topic for this tutorial then. Okay, now, the thing, it seems that the model is going to be ready. We had all the things we needed. We had two models with interaction and without interactions, both of them within the Bayesian framework. I'm just going to execute that by pressing Control-Enter, and it seems that not all objects have a Lu component. Let's see. Okay, now, you see that you do not have the Lu components yet. Then, how to just have the Lu components to the objects which we have? It's going to be very easy. We just have to just make sure that everything has a Lu functions next to that. If you remember from the things that we did, I'm just going to put the Lu here. And also for the second model, you see that we can just put the Lu, and by doing that, we have just given, I should say, the essence of the model is going to be like that. If we had to just convert when we have two models in the Bayesian framework, it's going to, as you saw that, we just get the error message when we just put, I should say, two models inside, for example, the Lu compare. We just get the error message that not all components have a Lu component, not all the objects have the Lu components. It means that before we just put our models, which we have fitted based on the Bayesian framework, our datasets, we have to just convert them into a Lu object. How to do that? We did this before. It's a tutorials that we did before. You remember when you just have the Lu, which it comes with the R-stand arm, you saw that the things that we had to do, normally all the things was that. We said that, for example, for this one, also, for the Lu, we said also the save, the Pareto, smoothed, important sampling, we're just going to put that as true. And also for the other model, we said that the save, this one also to be true. And you see that for the model comparisons, the thing that we do not directly just take the models as an objects, put that into the Lu compare to compare these models. We simply convert them into the Lu objects by using the Lu functions. And let's execute the line, and you see that now the code started and we have an output. Even without saving that into an object, we have an output. But how this output can be preferred? Look at that. You have this one as a difference. You have expected log of probability density difference, which is going to be 0, which is for the model with the with interaction. Model with interaction in the Bayesian has a ELPD difference as 0, but the model with no interaction Bayesian has, I should say, ELPF difference as minus 5.9. But what does it mean? When you just run the Lu compare, the model which is preferred, it comes first. And its own ELPD number is going to be subtracted from its own number. Imagine that the ELPD number, which we extracted, I should say, from the model which we had before, you saw that it's going to be extracted from on self, which is going to be 0, and also the ELPD number which we had from the model which it had the no interaction terms into the empty course dataset model that we had created as a Bayesian framework. It gives that number minus the ELPD number from, I should say, from the one which is a preferred model, and it gets the number there. Then by using the Lu compare, the model which comes displayed first and also comes with the ELPD difference as 0, it means that that's the better model, and that's the model that we have to just use that for our future analysis. That future analysis can be something you just want to go ahead and make some predictions. At this stage, for example, we have been able to compare two Bayesian models which we created, but with the Lu compare, you can also have the third model to be predicted, and always remember the model which is preferred comes at the top with the ELP difference as a 0. Whenever you saw your model which is on the top with the expected log of probability density difference as 0, stay assured that's going to be the model that you have to just move on with. Okay, now I think that's the thing we just wanted to talk about at this tutorial, how to compare two models. You can have 3 models to compare and 4 models to compare, all comes within the same package, actually the LuCompare. And now it seems that it should be enough for the tutorial that we had. You can also for some having some fun, you can also have the overlay density functions at the Bayes plot that we have done in the past in the other tutorials to see that how these models are replicating its own data sets of their own.